This session, we will be talking about the periodic trends as we look at the periodic table. Our essential question is, how can atomic structure be used to predict properties and periodic table trends? The objectives that we will be focused on are 3B1 and 3B2, all dealing with electronegativity, atomic radius, and ionization energy. Atomic radius is the size of the atom, or its actual radius from the center to the edge, half the diameter. The trend, as you look at the periodic table, as you go across a period, and if you remember, we talked about elements that are in the same period have the same number of energy levels. As we go across a period, the number of protons in the nucleus of the atom is continuously increasing, as well as the number of electrons. As these increase, the nuclear charge then pulls the electrons in closer and closer because there are more protons. So the nuclear charge is greater, being able to pull those electrons in the same energy level closer to the nucleus. As you go down a group, you're going to see that the atomic radius increases. The reason for this is each element that you go down increases in the number of energy levels that it has. This shows you as you go down a group, so from lithium to sodium, potassium, rubidium, and cesium, as we go down this group, we are seeing an increase in the size. And again, that's due to the increased number of energy levels. As we go across, we see that the trend is to decrease. And again, that's because of the increased nuclear charge or the number of protons. The next trend is ionization energy. Ionization energy is the energy that's required to remove an electron from an atom. The trend for ionization energy as we go across a period is to increase. The reason for this is because as we go across, we talked about that the number of protons are also increasing. Therefore, that nuclear charge is increased, which is what's holding the electrons there. And so it takes more energy as we go across a period to be able to pull an electron away. The trend as we go down a group is to decrease. The reason the trend is to decrease is because of those increased number of energy levels. Those energy levels act like shields, blocking that nuclear charge from those outer electrons that they're trying to hold on, and it becomes easier to lose them. The more electrons that you remove from an atom, that is going to give you an increased amount of ionization energy that is required. For example, if I remove one electron from a sodium atom to make it positively charged, then I have 496 kilojoules of energy that's required to pull that one away. Now, if I try to pull a second electron away from the sodium atom, then I'm going to need more energy. As you can see from the chemical equation here, it shows to remove that first electron, this is what we need. To go after a second one, to give it a positive 2 charge, it takes quite a bit more. Electronegativity. Electronegativity is the ability of an atom when it's forming a compound to actually attract the electrons. So we looked at ionization energy, and that's how much energy is required to remove an electron. This is looking at the atom itself and its ability to attract the electrons to it when it's forming a compound with something else. The trend of electronegativity is going to increase as we go across a period for the same reason we saw ionization energy increase, because the number of protons increases, giving the atom a stronger nuclear charge. The stronger nuclear charge, or the more protons that an atom has, the ability for it to attract electrons becomes easier. As we go down a group, since we are increasing in energy levels, we're going to see that our trend is going to be to decrease down a group. The reason that it's decreasing as we go down is that you have an increased number of energy levels. Now, some of them could remain the same, but in general, the trend is always to decrease as you go down the period. This is a periodic table with electronegativities on it. You can see here, if we go down a group, nitrogen has an electronegativity of 3. That's its ability to attract electrons. Phosphorus goes down to 2.1, arsenic goes down to 2, antimony 1.9, and then bismuth is about 1.9 also. So that's why we said they could stay the same, but the general trend, if you look from top to bottom, is to decrease. So a summary of all of the trends we've talked about, if you notice, whenever it's dealing with size, like atomic radius, we're going to decrease across and increase down. The other two, ionization energy and electronegativity, both dealing with amounts of energy and the movement of electrons, their trend will both increase across the period and decrease as you go down. The ionic radius, this is when you have an atom that has lost or gained electrons and is now an ion, which means it is a charged particle. Cation is what we call a particle that has lost electrons and become positively charged because it has more protons than it does electrons. As it loses the electrons, it will actually decrease the size because then you have fewer electrons and the protons are able to pull them in closer. And they can also be emptying out energy levels that are further away. Anions are the negatively charged ions, which form when atoms of nonmetals gain electrons. Since they are gaining electrons, so there's more electrons, there's more negative charges than positive charges, the size is actually going to be able to swell because the number of protons is fewer than the number of electrons now, and it can't pull it in as tight. This gives you a visual of the atom size versus the ion size. The atoms are represented in the gray portion, and the ions are represented with red for the cations, showing that their size will decrease, and blue for the anions, showing that their size increases.